All right, so let's continue our discussion of these electron configurations. And now we're going to move on to main group elements with an n greater than 3. So let's again draw our little diagram of our periodic table. Remember, we identify this over here as the S block, this over here as the P block. Remember the exception that helium, even though it's over here, it's still part of the S block. We call this one over here the D block. And so another name for some of this stuff, this D block over here is also called the transition metals. So we kind of already learned that. So these are the transition metals. And then all the stuff over here, the S and P block elements. Now let me pick a different color. Pink. S and P block elements are what's known as main group elements. So we're going to focus on those first. And then remember, in terms of our numbering, our D block is n-1. So up to n equals 1, 2, 3, it's looking pretty normal. But when we get to 4, things are going to get a little bit more funky. So let's first take a look at a picture. So if you take a look at this picture, it shows you kind of what I wrote up here, in that this D block is n-1. So you can tell here we go from 4s, but here we're only 3d. 5s, only 4d, right? And you can tell that the p's stay the same number, right? So 4s, 4p, but only 3d. 5s, 5p, but only 4d. And so that seems tricky, but you just have to remember this n-1. And again, just read it like a book from left to right, line by line. Let's copy our picture of our periodic table. And then let's take a look at some main group elements with an n greater than 3. So let's first take a look at over here. I like bromine. Bromine's a cool element. So let's take a look at bromine. Remember our little trick, we can just use the noble gas above it. So we can say bromine has the same electron configuration as argon and then some. So we have bromine there. Next up, we have this kind of 4s region, and we have 2 electrons there. So 4s2, right? We haven't reached bromine, so we're still filling up the electrons. And then we go over here, and we fill up all these electrons, right? We got to read like a book, left to right. You can't skip words in a book. And then the thing you have to remember is this is n-1. So while this is 4s, this is only going to be 3d. And then if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 electrons in these d orbitals. And that makes sense if you think about what d is. It's L equals 2, and so m sub L can be 5 values between -2 and +2. And then we keep going until we reach bromine, right? So again, now we're back to the 4. So 4p1, 4p2, 4p3, 4p4, 4p5, 4p5. So that's your electron configuration for bromine. And then think about how many valence electrons does this have. So how many valence electrons have? Remember, find your highest n. Your n here, your highest n is 4. So if you count those electrons, we have 2 plus 5, that's 7 valence electrons. So bromine has 7 valence electrons. So that makes sense. We said everything in this column has 7 valence electrons. Note that the d electrons are not in the highest n, so they do not count as valence electrons. Go ahead and erase all this stuff. Let's try another element. Let's try tellurium over here. Tellurium, right? So you can pick the noble gas right above it. So we say tellurium, Te, has the same electron configuration as Kr, krypton. And then where are we at? We're at 5s2. 5s2. And then we got to count all 10 of these electrons. Remember, these are n minus 1. So if we're in 5s, this will be 4d because 5 minus 1 is 4. And there's 10 electrons there. And then 1, 2, 3, 4. Remember, we're back at the 5p, 4. And so this has 6 valence electrons, which makes sense because that's exactly what we would predict as before. I guess I'll show you guys this little trick. This pt8.com website is very, very useful. So if you go on this pt8.com and then you hit this orbitals button, right, it shows you orbitals, and you can see it's moved helium over here to show you that it's in the s block, right? And so you can see as I move down, if you pay attention, it shows you your orbital diagrams for all of this stuff, and then actually the electron configurations as well. So it's almost kind of like cheating because it just dumps out the answer right there. So you can see bromine right there. You see they don't use the noble gas configurations, but you can see it ends with 4s2, 4p5 for 7 valence electrons. So again, this website is very useful. You can see all the electron configurations. You can take a look at what these orbitals look like, play around with this website. It's super cool, super useful.